All right, guys, before we get started, are there any questions over any of the assignments so far?
I went over the last homework and I looked at all of them and I didn't get anything.
Do you have one of those in particular you want to look at? Friday was a makeup day.
Make up there.
Because those are chapter 8.
Oh, exactly.
So from Thursdays, so one from here.
Yeah. I don't have a particular one because I tried all of them and I didn't know.
Like number 3. So 9 squared to the 1/3. Which would be 9 to the power of the powers
That's it.
multiply. 252. Too far. 253. Yep, that's it.
And then number 12 to 2.
Which is 2/4 is the same as. Yep. The only reason we would have to go simpler than that would be if we had something, say, 4 to the 3rd to the 1/2. Because this would be 4 to the 3/2. But the 1/2 is the same as the square root. And 4 is 2 squared to the 3/2, which gives us 2 to the 3rd, which is 8. Because if we can reduce that power, we're going to want to. Now here, I mean, we could have said this is 3 squared to the 2/3, which is 3 to the 4/3, but that's not reducing the fractional exponent. So we'll just take that there. All right, guys. So looking at this here, we have these 3 again. Now, you're not having to rewrite them back out. But for it to be in simplest form, no radicals can have perfect nth powers as factors other than 1. No radicands can contain fractions. And no radicals can appear in the denominator of a fraction. Now, 2 of our properties that we're looking at today is the product property. If we have 2 things multiplied inside a radical, we can split it up as the 2 radicals individually. Or we can go the other way around. We can take 2 radicals with the same index, same root, and put them together. So we can go one way or the other. And that's helpful, especially for the 3rd root of 4 times the 3rd root of 2, the cubed root of 4 times the cubed root of 2, because we can't take them individually. But if we do multiply them together, we get the cubed root of 8, and the cubed root of 8 is indeed 2. So we can take the cubed root of the one whole, but we couldn't do it as individual parts. Now with division, if we have 2 things being divided inside the radical, we can split it apart. Or we can put it back together. Whichever way is going to make it easier to solve. Now if we look at the first one here, the cubed root of 12 times the cubed root of 18. Clear all that out. So if we take the cubed root of 12, we get a decimal answer. If we take the cubed root of 18, we get a decimal answer. So we can't take those individually. But if we multiply them together, the cubed root of 12 times 18, So we do 12 times 18 in the calculator. 216. Now at this point here, we can try taking the cubed root of 216 in the calculator. If it gives us a nice number, that's our answer. If it doesn't, we have to do a little more work. So here it's 6. Now the other way we could have gone about finding the cubed root of 216 is our prime factorization, our factor tree. So one number that we know is if multiple of 216 is 2. So we can say 2 times 108. Well, 108 is 2 times 54. 54 is 2 times 27. Well, we can't divide 2 into 27, but we can do 3, which is 3 and 9. And then we get 3 and 3. So 216 is the same as 2 to the third times 3 to the third. So what we could have said is we're taking the cubed root of 2 to the third times 3 to the third. Now we can break this back apart with our product property. Saying we have 2 to the third, the cubed root of 2 to the third times the cubed root of 3 to the third, which is just 2 times 3, which is indeed 6.
Instead of going through all your steps in 216, can you just take 2 associated with 12 and 8?
So 12, so I'll erase this here, because 12 is 3 times 2 squared, 3 times 4, cubed root. 18 is going to be, so 2 times 3 squared. Now we can't take the cubed root of any of those individually, but if we multiply them together, 3 times 3 squared is 3 cubed. 2 squared times 2 is 2 cubed, which gives us 3 times 2, which is 6. Yeah, either way we get to the same answer. Does that make sense? Now, with the division, can we divide 80 by 5 nicely? Yeah. So what we can do is make this one rational expression. So we get the fourth root of 80 divided by 5. Well, 80 divided by 5 is? Now we just need to take the fourth root of 16, is 2. And when it works out nicely, we could have done this from the beginning. Fourth root of 80 over the fourth root of 5 is 2. So if it works out to be a nice number, the calculator can do it. Now, the cubed root of 4 times the cubed root of 128. Now, what we could do is, like you were saying earlier, is I could, instead of just multiplying them together, we can do our primes to start with. Because rewriting 4 as a product of primes, 2 squared, is not too bad. Now 128, well, that would be what? 2 times 64. 64 is times 32 is 2 times 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. Well, we got 1, 2, 3, 4, 5, 6, 7. And if we multiply these together, we get the cubed root of 2 to the 9th. And what would the cubed root of 2 to the 9th be? So this is going back to the other day, the nth root of a to the x is equal to a to the x over n. I'm doing this as an easier way to see what it is, because it will get you to that number you see on the calculator. Because here we're saying we have 2 to the 9 over 3. Well, 9 divided by 3 is? And 2 cubed is 8. Does that make sense how we got there? It's just breaking it down. Now, if we'd multiplied them together at the beginning, it would have been 556, no, 512. Yeah, would have been our number. And then it's just doing it from there. Because I can just move that down. And we have another 512, 256. We had another 2 2s from our 4. Does that make sense? A lot of this is just figuring out what the prime numbers are. Because we already had 7, this would make 8, that would make 9. Any questions on this here? Now, the last one of this type we're going to look at. Now, does 192 divide by 6 nicely? Yeah, so we'll divide it. And if we divide it, we get, and the fifth root of 32 is? And that's it. I mean, for this one here, we could have just typed it in the calculator from the get-go, and it would have given us the answer. Welcome. Now let's look at the next one here, the cubed root of 135. Can we take the cubed root of 135? No. Now they want it as a simple, in simplest form. Now it gives us a non-repeating, non-terminating decimal. So we have to look at the perfect cubes, or we want to find perfect cube factors of 135. Now 2 doesn't go into it, but what's the next prime number that will go into 135? 5. 5 goes into 135 27 times. So we have 5 times 27. Now 5 is prime, 27 is not. What is the smallest factor of 27 besides 1? And it'd be 3 times 9. And 9 would be, so 135 is 3 cubed times 5. And I mean, if we want to make sure we can do it in the calculator, we can say 3 to the third times 5 is indeed 135. So what that's telling us is that we're taking the cubed root of 3 to the third times 5. Now if we want, we can split this into 2 statements. The cubed root of 3 to the third times the cubed root of 5. Well, what is the cubed root of 3 to the third? 3. And we can't take the cubed root of 5, so we have 3 times the cubed root of 5. And that's it. Any questions on how we did that there? Now we're going to skip over to the 500 one next. We'll do the division 2 together. Cubed root of 500. Can we take the cubed root of 500? No. So we have to factor tree to see what our factors or our prime factors of 500 are. So what's a number that goes into 500 nicely? 2. And that'd be 250. 2 is prime, so we can look at 250. 250, what will go into it? 2 won't go into 125, but what will? 5. Be 5 and 25. 25 is? And 5. So 500 is the same as 5 cubed times 2 squared. If we could do that in a calculator just to make sure, 5 to the third times 2 squared is indeed 500. We got the right number. So what we can say is the cubed root of 500 is the same as the cubed root of 5 cubed times 2 squared. And again, we can split those apart. The cubed root of 5 cubed times the cubed root of 2 squared. Well, the cubed root of 5 cubed is, can we take the cubed root of 2 squared? No. So we'll have our cubed root, but we won't write 2 squared, because what is 2 squared? So we'll simplify it. So if we can't reduce the radical with the exponent, we just simplify it back to whatever the number was. Any questions on these here? Because I think simplifying these radicals is not too bad. It's just figuring out what the prime factorization is and then simplifying with the root. Now let's look at division. Fifth root of 7 divided by the fifth root of 8. Will 7 divide by 8 nicely? No. So the reason we do that is to make sure we don't have a radical in the bottom of a fraction or a fraction inside of a radical. And up to this point, every single quotient or fraction simplified nicely. So what we're going to do now is rewrite the numerator and denominator in our prime factorization form. Well, 7 is just going to be 7 because 7 is prime. There's no way to rewrite it. 8, on the other hand, would be 2 times 4. And 4 is 2 times 2. So 8 is 2 cubed. So we couldn't take the fifth root of 8, yes? Can we take the fifth root of 2 to the third? No, I mean, if we couldn't take the fifth root of 8, 2 to the third is just 8, so there shouldn't be any way that we should be able to do it now. Now, we have 2 to the third. We have 3 2's, yes? How many 2's do I need total to simplify with the fifth root? How many do we need? 5, yes? How many am I missing? 2. So what we can do is we can multiply this on top and bottom by the fifth root, because we need the roots to be the same, of 2 squared. Because we're going to multiply the denominator by however many factors we need to get it to simplify out. So here, the only one we have is 2, and we need 5 of them to simplify with the fifth root, because that's the next amount that we need. So on the bottom, we'll have the fifth root of 2 to the fifth, which will simplify to just 2. Now we do need to multiply the numerator. So we'd have the fifth root of 7 times 2 squared. Because the indexes are the same, we can multiply what's inside together. So we can, in the calculator, we can say 7 times 2 squared, which is 28. So we have the fifth root of 28. Because our 2 squared is 4. 4 times 7 is 28. Questions on this here? Are you ready for the next one? 19 over the fourth root of 19 over the fourth root of 4. No, they don't divide nicely. And 19 is prime, but 4 is 2 times 2, or 2 squared. So incidentally, we do have 2 again. So we need to multiply top and bottom by the fourth root of what? 2 squared. Because the next power after 2 that we would need would be 4. So we multiply it by 2 squared, which would give us the fourth root of 2 to the fourth on bottom. On top, we have the fourth root of 19 times 2 squared. Now the denominator is 2, 68, or 78, 76, yep. It was a little bit bigger than that. Because we'd have 19 times 4, which is indeed 76. And that's it. Questions on any of this here? And again, a lot of this here is just manipulating the numbers to make it work so we don't have radicals in the bottom of the fraction, or in simplest form. Now again, we can't have a radical in the bottom of a fraction. So what we're going to do is multiply the top and bottom of this fraction by the conjugate of the denominator. And all that means is we're taking the denominator, our 5 and square root of 3 here, and just changing the sign in the middle. So we're multiplying top and bottom by the irrational conjugate. So that the radicals in the bottom would cancel. So if we multiply, well, 1 times 5 is 5. 1 times negative square root of 3 is negative square root of 3. Now if we multiply the denominators, well, 5 times 5 is 25. 5 times negative square root of 3 is negative 5 square root of 3. Now we can do square root of 3 times 5, which is going to be plus 5 square root of 3. And lastly, we can do square root of 3 times negative square root of 3. Well, positive times a negative is a. And the square root of 3 times square root of 3. Well, that'd be square root of 3 times square root of 3. What we can say is the square root of 3 squared. And what is the square root of 3 squared? Because the square root and square would. Now, square root of 3 times square root of 3, we can multiply what's inside. 3 times 3 is, what's the square root of 9? Now we have got almost all the radicals in the denominator gone, but we have 2 left, yes? 5 square root of 3 minus 5 square root of 3 is 0. Yeah. 1 over 5 plus square root of 3. 1 over 5 plus square root 3. Now they do have it flipped. They put the radical first, but 5 minus the square root of 3 and negative 3, or negative square root of 3 plus 5 are the same thing. And we get this here. Questions on this here? Now it doesn't matter which order our radicals are, because we could have the square root of 7 minus 2. It doesn't change what we would do if we did this by hand, because here we would just multiply both sides by the square root of 7 plus 2. Now we multiply both of these by 1, we just get the square root of 7 plus 2 back. Now the denominator, square root of 7 times the square root of 7 is just 7. Square root of 7 times 2 is going to be plus 2 square root of 7. Negative 2 times the square root of 7 is negative 2 square root of 7. And negative 2 times 2 is negative 4. These here will cancel, leaving us with 3 on bottom. And square root of 7 plus 2 on top. And that's it. And as I pointed out already, the 30xs will do these here. Square root of 7 plus 2 over 3. And that's it. Any questions on any of these here? No matter what it is, we can plug it in for these here, and the calculator will give it to us. Now, if the calculator doesn't give it to us, we just would do it by hand, multiply top and bottom by whatever the denominator is with the sign in the middle changed.